So first, what is linear regression, right? Linear regression. Regression means to continuous print or predict continuous valued output, right, based on some previous data, right? And linear means line. So linear regression is basically the algorithm that predicts continuous valued output using a line, right? So first I will go through a step by step process in case of linear regression, right? So first we have something called training data, right? And then we have something called a linear regression algorithm, linear regression algorithm, and from that we get some hypothesis, and there is my testing data or test data, and I get my prediction, right? So first I pass the training data to the linear regression algorithm, and this linear regression algorithm gives me a hypothesis. I pass the test data to the hypothesis, and that gives me the prediction. After the prediction we go for the cost function, right? So I think up to this is clear, right? So now what is the hypothesis? Hypothesis is basically h theta of x equals to theta naught plus theta 1 x, right? What is theta naught? Theta naught is bias here, and theta 1 is weight, right? This is my input feature, and this value is my prediction, right? Now a lot of the times the prediction is not correct or not good. So how what we have to do in the case of linear regression is basically we quantify the prediction, right? So for quantifying the prediction, what we do basically is we use something called cost function. Before understanding cost function, we have to understand loss function. What is there in case of loss function? We use MSE, that is mean squared error loss function, right? Which is basically y, let's say I for some specific values, right, minus h theta of x whole square. Yi is the original output, and h theta of x is the prediction, right? Prediction. Now when we extend this to the entire data set, we get cost function, which is basically equal to 1 over 2m sigma I equal to 1 to m y I minus h theta of x I whole square, right? And after this, what we do is basically we go on to understand gradient descent. What we do basically in gradient descent is we update the gradient descent. What we do basically is we update the parameters, right? Update the parameters. How? So the formula is basically theta naught equals to theta naught minus alpha times cost function theta naught theta 1 divided by partial derivative of theta naught, right? This is the formula for the gradient descent. Now I know you're not understanding this very well, so let me explain. Theta naught is actually updated, like x is equal to x plus 1. Similarly theta naught is actually updated, right? So cost function, when we differentiate the cost function, in general a cost function has somewhat a parabolic uh, structure, right? So let's say initialize a variable here, right? So what I'm going to do basically after initialization is that I'm going to draw a slope, right? The slope is negative, so if the slope is negative here, so this negative negative will be positive, so I'll increase the value of theta naught, which will gradually go towards the, so I'm increasing it, means we are going towards the minima. Now I'm taking a value here, maybe initialize it here, right? So now I'm taking a slope, and the slope is basically positive, so theta naught minus some value, so the value will be going like this. So initial, and finally we will approach this, right? So this is basically the linear regression algorithm in the simplest way and in the quickest way. I hope you have liked it, and thank you.